So hello guys, welcome back to my channel. After a 2 day long break, we have started the Stack and Q series in Code with Vishesh. So let's continue our journey with a new topic. So for today, we have completed the basic of Stack and Q, where I have used the implementation part, and I will tell you the how and what are the main implementations of Stack and Q. So we will be going and taking stack and queue together, and we will be solving multiple problems based on stack and queue. So for the stack, basically it's a data structure that works in first in uh, leaf order, that is last in and first out. That means we will be putting the elements in a bucket, and we will be taking the first element that is on the top of our bucket. So basically we will taking off the element which we have put at the last. So that's last in first out. While queue is also a data structure that is used to store multiple elements. They may be a int, char, any pair or anything. So that works oppositely and work as a first in first out. It's like a queue in our prayer times in schools. uh, the person who is in the front of our queue goes first in the class, while the person who is in the last wait till its turn, and it goes when all the queue elements have gone. So that works in a first in first out order. So for the stack we have operations such as push, pop, top and size. These are the main operation, and we can also say that these are similar operations for queue as well. So for the queue we have push, pop, top and size. So I have told over the what is queue and what is stack. So firstly we will be implementing stack by using an array. So in this we will be taking an array and we will be implementing stack based operation in our array. So we will be creating a class, and in the class for the push operation, if our array size, because array is a limited size, so we will be taking limited number of elements for the stack. So for this, if our size, if the number of elements are greater than our size, so we will be stopping. Otherwise we will take top, and we will be incrementing our top in our given array, and for initially we will be initializing the top with -1, and after this if there is an element we increases our top and go and make the new element entered in our array and increase stack dot top as +1 value. So that's how we push. And for the pop function, if our top is -1, basically our array is empty, we will return back. And if it is not the case, so we will be returning the stack dot top element. And for popping function, we will be subtracting the element and removing the element from our array. So that's how we can pop. And for size, we can simply return the top +1 for our size, as elements are in array. So arrays go from 0 to n-1, and our total size will be n. So that's how some function will be implemented of stack using array. Now coming upon queue using array. So for this, in our queue we will be taking two elements, front and start and end, because queue is first in first out element, so we have to maintain the count. And for this we will be making a class of queue, and for push operation we will be checking if current size is equals to the given size, so we will be returning. And if size is equals to 0, then we will be increasing both stack start and end. Like initially start and end are initialized with -1, and if the queue is empty, if the array is empty and we have a new element entered in our array, so we will be increasing both start and end with 1. After this, if it is not the case, then only we will be increasing our end, and in our queue, suppose we will be moving forward, and we will be taking the modulo of end plus 1 modulo size. I will be telling further why we have taken this, and we will be inserting that q dot end element and increase our current size. So suppose we have a queue, and in this we have put in all the elements, and if pop operation arises, so we will be popping out the first element, and that area will be vacated of that array. So for, and we have now a new element, so we want to put the new element in our current array, and because our end value will be reaches to null, or size, it goes beyond size -1, so how you can put that element? So for that we will be taking this modulo operation of n plus 1 modulo size, so that we can use the given our first block that is vacant for now, so we can use that element, that space of array, and that's how we will be applying the push function. For the pop function, we will be checking if current size is equals to 0, means there is no element to be pop out, so we'll return simply our start, and if the current size is our if current size is equals to 1, that's the single element in our queue, so we will be using start equals to n minus 1. Else we will be same taking the modulo operation, and start goes to start plus 1 modulo of size, and our current size decreases to -1. So that's how we will be able to do pop function. For top and size function, we will simply return the q dot start or current size. So that is the stack and queue using array. So the complexity for both is much more higher, like their time complexity is big of 1, while space complexity we are taking an array, and most of the part of our array is just wasting, like we have only 3 operations and we are taking the space of 10 to 20 elements specific array size, so that's how our most of the area got wasted. So for this we will be using stack using linked list. So in this we will be using linked list as a data structure and implementing the stack firstly, and we will implement queue also. For the stack, we have to understand if there is a new element, simply our linked list will points to that null, and if a new element enters, like we have 4, so we will be taking a 4 and insert our top as null, and after this if we join new element as 2, like 4 then 2 then 3, so if there is 2, so our we will be connecting our 2 with our next node, that is 4, and in our top will go from 4 to 2, it get changes. So we will be using temp for changing of top, and for this we will be making a class again. For the push operation, we will be taking temp as the new node x, and temp's next goes to top, and top is equals to temp, and after this our size will be increases, so that's how we can push the element. And for the popping of the function, our temp goes to top, and top goes to top dot next, and now this we can delete the temp, and after this we can decrease our size equals to size -1, that's how we can pop. So basically we are using linked list and connecting the nodes. If there is a new node arising, so we will be connecting that node and making our top pointing to that node, and that's how it will be work, like LIFO, that is last in first out. So our pointer is pointing, our uh, top pointer is always pointing to our last node. So that's how LIFO works. And for queue using linked list, we have to take two elements like start and end to making the nodes, and our size will be initialized as 0. For the push operation, our we will be creating firstly new temp node, that is our new node. And if our stack is null or our stack is empty, so our start and end both goes to the temp. And else if our ends next will be as temp, and our size got increased by 1. And that's how we will be able to put the elements, like it will be just opposite to our stack. Like if there is a new node arising, so our pointer will be pointing to that new node. And our start pointer will go a start pointer will be stay at our first element, while our end pointer goes on and on. And if we want stack dot top, so our stack start pointing is on the initial node, so we will be pointing to that node only. And if we want to pop out that node, so we will be popping out our start node. And uh, uh, for calculating the overall size of the queue, we can maintain the count, like number of push operation minus pop operation is the our size. So that's how we can push and pop elements. Now we will be implementing stack using queue and queue using stack. So for stack using a queue, we have a stack data structure and we want to make it work like a queue. So for this, we will be making a new stack class where queue will be our data structure, and we will be implementing push x. Suppose we have to enter 4925 as the element. So our main target will be to put them in the our queue. And if we want the top element, we have to firstly reverse them all the numbers. So our target will be our size will be a q dot size. And for pushing of operation, we will be running a loop from 1 to size minus 1, q dot push q dot top. So q dot push, or and inside this q dot top means we are pushing the new elements that are arising. And q dot pop, after this we will be using q dot pop. So we are taking a number like we inserted the 4, then we inserted 9, and now we want to insert the 2. So before inserting 2, we will reverse the numbers, so our 4 will be go beyond 9, and then 2 will be inserted. After this, if we want to insert new number as 5, so firstly our q dot top means our starting element, that will be 2, and then 9, then 4 will insert after 5 as 294. So that's how our order will be maintained for the queue, and our stack will work like as a queue. So for this, our complexity reaches to big O of n, and time complexity is big O of n, and move on for the push operation, and for all other operation it reaches big O of 1. And for the queue using stack, we will be implementing using two stacks. There we have two stack, and we will be utilizing them to make the operations for the queue. So firstly, we will be putting the for the push operation. Firstly, we will putting all the elements in our S1, and we will be making the copy of S1 in S2, and then we will be putting the new element in our S1. And after this, our if there is element in S2, we will be copying that back into S1. So that's how our queue will be formed using stack. Like stack is LIFO and queue is FIFO. So we are just copying our all the elements of first stack in second stack, and Then we are inserting the new element in our first stack and putting back a second stack's element by LIFO order in our first stack. So eventually we are making our first stack as a new queue. So that's how our queue operation will be implemented using our stack. And this is the introduction video of stack and queue. Hope you like this video. And with this our stack and queue journey starts. Our target is fixed as earlier. And with all wishes, good night, sweet dreams, and